start this recording. Here we go. Welcome. You know, have a lot of fun with this chair too. I wonder if I just got them to cut it just like a little bit. Cut it down a notch. Okay, so where do we start? At the beginning, what is statistics? Well, that's a good place to start, huh? Everyone always used to ask me when I was in grad school doing statistics, everyone's like, oh yeah, so in baseball, who has the most? I'm like, I don't, what? Those are statistics, yes, but that's not what we're doing here, right? And so what we're doing here is we're learning from data, right? And analyzing data. Statistics is also collecting data, of course, summarizing data. There's all kinds of things, but let's see here. Oh, I like it. I'm gonna go for a thicker pen. This is difficult. Okay, don't be offended. I'm gonna turn it this way. I don't know what's better, sitting down or standing up behind a chair. It's always a chair in the way. Statistics. And remember, I'll post these notes afterwards, right? And so if you want to just sit back and have a nap, I guess you could do that. I don't know. Good luck. I'll be talking the whole time. But I had a dog that passed away, but when I was teaching online, she loved it because it was just my voice droning on and on, and she would just sleep in a chair. So that's what I imagine you guys doing as well. Statistics is defined as the science of collecting, analyzing, and drawing conclusions from data. We got a little wobble. I don't know. Collecting, analyzing, and drawing conclusions from data. So this chapter is a little bit overwhelming in a way because there are so many terms that we need to know, right? But just like any language that you're learning, you need to know the terms so that we can talk about things, so that when I say a numerical variable, you know what that is, right? And so chapter 1 is basically establishing all these terms that you're going to need to know. And I know that's annoying, but that's just how it is, okay? Data is usually collected from surveys. So there's a few different ways that we collect data, and you can probably name them all already, right? If you kind of think about it, right? You can collect surveys, you can do experiments, or we can just observe information, right? And those are called observational studies. So data is usually collected I think I did the wrong leg. I'll just go through and try all the legs. It's usually collected through sampling surveys, observational studies, or experiments. Try to keep it on this one line here. We'll talk more about those in a little bit. We're not going to go into great detail about how to collect data because that's a whole field of its own. And so we're not going to do that. We're going to always just kind of assume that we've collected data. We're going to talk about some of the sampling strategies that we could use, right? Just so you're not completely lost when you're reading a study or something like that, right? But in terms of collecting data, just know that that's a whole field of its own, right? And so we're just going to touch in and then back off, and then we're just given our data. Okay. So chapter 1 is not surprisingly called Introduction to Data. And section 1.2 is called Data Basics. Right. 1.1 was that case study about the stents, just to kind of get you, I don't know, percolating about what we're going to be doing, right? The things that we need to be thinking about. So data basics. We assume we have some data set and like, hello? It's kind of fun because it's like, you're on TV? Hey guys. TV, no. Anyways, we're going to assume that we have a data set, right? And if you think about a data set, how do you imagine a data set in your mind? Probably some sort of Excel spreadsheet, right? Just kind of intuitively, how do you store data? Well, it's going to look like a spreadsheet, right? And that's usually how it's stored. And I'm going to steal this figure from the textbook. I try to write out all our notes by hand so that, you know, it's kind of a reasonable amount to be writing together. But sometimes I steal from the textbook. But I try to include the figures so that you can reference it and maybe go back and grab it yourself. Okay. So a data set might look something like this. Right? And so this data set is about loan amounts, right? So a bank has information on how much people have loaned, what the interest rate is, what the term of the loan is, what the grade of the borrower is, probably some sort of lending score, the total income, and their home ownership status. Right. And so to be able to talk about data, of course, we need to be able to talk about what all these components are, right? And so just some key terminology today, and maybe I'll make this, hey, I thought I was making it smaller. Make it a little bit smaller. Okay. So just in general, this whole thing, right? That whole thing, we can call it a data matrix, which makes it sound cooler than a data set for some reason, right? And so a data matrix, so this is a data matrix. I can't remember where you start in 314. Is everyone taking 314 if you're in data science right now? Maybe. Do you guys start with linear algebra or do you start with the calculus bits? So you know what a matrix is. It's a thing of values that looks like this. Okay, but usually we call it a data set. Jury's out on whether it's 1 or 2 words, so I flip-flop back and forth. Set of data. Okay. So I usually call it a data set, and a data set has some number of observations, right? And so each line makes up an observation, and there's lots of different terms that we could use, right? Each line is a case, or the I'll jot down observations, but I think I heard sample size. Well, the number of cases, let's jump there. The number of cases that we have is our sample size, right? And a lot of our analyses are going to depend on our sample size. So that's really important that we kind of get that out of the way. So here, I'll put it outside. The number of observations or rows in our data set is our sample size. Is our sample size, and the sample size, we'll just get this out of the way, is denoted by a lowercase n. So if you're reading studies, things like that, they'll usually include in their reports, little n is this, right? And we'll kind of get a better understanding of why they do that, right? But in general, a larger sample size gives us more robust estimates, and so that's where we're headed. Okay, but our sample size denoted by a lowercase n. Where we're going to focus today are these guys, the columns in your spreadsheet, let's say. These are your variables. So generically, they're just known as variables, but you might be aware that there are different types of variables, right? And so we need to be able to identify what types of variables we have. In fact, the type of variable that we have is going to determine our analyses. And so what I want to do is I want to give you an overview of where these variables are in the chapters. Okay, so we're going to start by analyzing categorical variables. Okay. For example, if you look at the home ownership variable, right? That's different information, right? There's only so many categories, spoiler alert, right? Versus income, right? Which would be kind of intuitively numerical, right? And so we need to be able to kind of decide which type of variable we have, and then that will dictate the analyses that are appropriate. Okay, so that's why it's so important that we understand what variable I have, and then I can go from there. Okay, because I have a categorical variable, I can do these things, right? So in general, I usually like to start with, I have a variable, and a variable can really only be split into two groups initially, right? Don't worry, depending on what field you're in, I know psychology especially, they have like 17 different categorical variables, depending on, you know, if there's some distance between them and blah, 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 blah. And it's crazy, but for us, for our purposes, we're just gonna focus on this main split of categorical variables and numerical variables. Okay, so categorical or numerical. I like that terminology because when I say categorical, most of our minds go to categories. Okay, we kind of have an understanding of what a categorical variable is, even though I haven't defined it or anything. Same thing with numerical. If I say numerical, you hopefully start to think number, and it's some sort of measurement, right? That kind of thing. And so, but of course, there are other synonyms, like terms, that we could use. So instead of categorical, we could say qualitative, but I find that a little bit harder to wrap my head around intuitively. quantitative. But again, depending on what field you're in or have been in, right, they might do some mashup of that. I think in some data science books that I've read, they go for a combo of qualitative and numerical. That's weird, right? I don't know. I don't make the rules, but it's our job here to understand that, okay, I can use these interchangeably, right? Categorical and qualitative. Qualitative because it has some quality, right? That we can then put into categories. We end up at categorical anyways, right? And then quantitative because it's some measured quantity, which makes it a number, numerical. Okay? So let's see here. I'll just do a little, a quick summary here. So observations, if they're categorical or qualitative, observations can be grouped into distinct groups. Can be grouped into distinct groups. You'll notice, so here it's a very subtle page break. I'll do weird stuff in my notes, but then when I produce the PDF and I post it, then they'll be on separate pages. So sometimes things look weird, but then when I produce the PDF, it's all fine, hopefully. Whereas for the numerical data, right, your observations are measurements, right? So just in general, they're measurements. So observations are measurements. Okay. Things like speed, distance, time, etc. I tell you about the page break and then I ignore it. The chapters of the textbook won't make sense right now, right? But it's nice to have kind of a roadmap of where we're going, right? And so in terms of where are we going with this, right? We're going to analyze categorical data in chapters 5 and 6, right? In terms of the analyses, okay? And then numerical data will focus on the analyses in chapters 7 and 8. Hold up, Emily, we're only in chapter 1. What happens in between? Some stuff that we have to do to check some boxes, okay? It's the meat and potatoes of this course is this stuff here, right? Once we get into chapter 5 through chapter 7, that's why we're here. And so the stuff before then is just kind of leading up to that. Okay? And also there are certain boxes I have to check to say that you have done this course. So you'll see what I mean in chapter 3. Okay. So what I find helpful, especially for identifying a numerical variable, because sometimes it can be a little bit tricky, right? And sometimes there isn't a clear answer to what type of variable you have, okay? But one of the questions that I like to ask myself is, does it make sense, or am I interested in the average of something, right? If I'm interested in the average of something, then I'm going to treat it as a numerical variable. Whereas if I'm more interested in what the categories are doing, right? How many people are in this category? How many people are in that category, right? Then I will treat it as a categorical variable. So part of this course, again, is just kind of developing the arguments that you use, right? I treated this as a numerical variable because I'm interested in the average. Okay. And so you'll see there are cases where it could go either way, and you just need to argue to me, as long as you argue reasonably, right? I treat it as a numerical variable because I'm interested in the average of it. I can't argue with that, right? That seems reasonable, right? I treated it as categorical because I was interested in the categories, right? So here, for the numerical, ask, I guess, yourself, do I want to know about the average? Do I want to know about the average? Okay. If I do, I will treat it as a numerical variable. If yes, treat it as a numerical variable. As an example, right, if you go around the school and you ask students, what year are you in? Right, they're going to tell you first year, second year, third year, fourth year, fifth year victory lap, right? You guys are a little bit different. First year data science, second year data science, right? But it would still be 1, 2, 3, 4, 5, right? And so what are you gonna, what type of variable would you classify that as? I bring this one up because I could go either way, right? I would probably treat it as categorical because talking about the average year that someone's in can only tell me so much, right? I might want to know, okay, this proportion of the school is in first year, this proportion of the school is in second year, right? But it does depend on what you want to talk about, right? If you want to talk about the average, you treat it as a numerical variable, right? And so there are often going to be categorical variables that are numbers, right? And so that happens and it gets very confusing, right? But as long as you know the arguments, then you're on the right track. Did I have that, or do I need to take it from memory? Okay, so for example, if we ask students on campus what year they are in, the answers will be 1, 2, 3, 4, 5. We'll stop it, and then let's say 5, 6. I guess it could go on, but the answers will be 1, 2, 3, 4, 5. I'll do a period there. There could be more, but we'll just stop there. Yeah. So here, right, I'm going to write down the arguments for either or, right? To me, I would lean more towards making it categorical, right? And so if you want to argue, or here, let's say here, we could argue either way on what type of variable this is. Oops. Can be categorical, right? Since I'm interested in the proportion right? We haven't talked about proportions, but proportions are, 300 out of 1,000 students are in first year, right? And so, and we'll talk a lot more about proportions, but for now, if I wanted to treat it as categorical, I would say, since I am interested in the proportion of students in each year, I will treat it as categorical. The proportion of students in each year, I will treat it as categorical. Whereas if I wanted to treat it as numerical, what would my argument be? I would say, since I'm interested in the average year of the students on campus, I will treat it as numerical. And so those are the two arguments that you can use. Since I am interested in the average year of school of students on campus, I will treat it as numerical. Yeah. If you ever need me to clarify what I wrote, just let me know, okay? But that is why I read it out loud as I write it. But I will fix that one. That one's weird. Treat. Okay. So just be aware that there are going to be cases where, I don't know, you could convince me either way, right? But you need to know what to say to convince me. Okay. Sometimes I might say, do you really want to know about the average of that? Right? Maybe not. If we talk about, so if I scroll back to this data set, right? And if so I haven't given you the data descriptions or anything, but just going with kind of our gut here, right? If I talk about the loan amount, right? An amount is usually numerical, right? And so the loan amount I would classify as numerical, and it also makes sense to talk about the average loan amount, right? And then, so same with the interest rate, I would classify, so I personally would classify it as numerical, right? These are kind of obviously numerical in my mind. Then we get to the term, and just by looking at the head of the data here, 36, 60, 36, there seem to only be certain terms, right? You can't just choose a term, right? There are maybe 3 or 4 different terms. I guess you choose from 3 or 4 different terms, right? And so I would probably talk about term as a categorical variable, right? And the reason for that is because if I don't have any other options between 36 or 60, that's all I see here. So let's just say that those are my only 2 options, right? The average of those, it doesn't tell me anything, right? So then I would rather know about, okay, this many loans were on a 36-year term and this many loans are on a 60 years, months probably. Yeah, unless it's a house. But for 7,500, I hope it's not years. It's crazy. Then we have these kind of, I'll say obviously categorical, right? As soon as we have, grade A, B, A, right? Just right off the bat, it can't be numerical. It's not a measurement, right? And so, and same thing with the state, obviously, that's going to be categorical as well. The total income, I'm going to go for numerical again, just because it's a dollar amount. As soon as we have dollar amounts, it's numerical unless, haha, there's always an unless I change it to income categories, right? But those are things that we're going to pick up on, right? And you're going to see income categories and say, well, one, it has categories in the name, so probably not, right? And what we'll find is that we can turn numerical data into categorical data, but you can't reverse it unless you have the original data, right? So we can always turn numerical data into categorical if you want to, right? But not the other way around. And then home ownership, of course, categorical, easy, right? And so for us, right, just this week, we just want to get really good at looking at something like this and having kind of that gut reaction of numerical, categorical, right? And then that's going to serve us throughout the term. I will kind of go back to, I don't have any room. So I have a variable and it can be categorical or numerical, right? Just kind of going back to those branches and just if you just focus on these, but just to be aware that there are other sub-classifications that we could do, right? And so I just want to mention those before we move on. They're just something to be aware of, right? Aware that they exist. And like a lot of things, just knowing that it exists, you can look it up, right? And so how's your R programming going? It's okay. It's good. It's fun. No, maybe not. Not in the beginning. I usually say when I teach R, I always say it's not going to make any sense for the first half of the term. You just got to keep going. Just keep at it. Just keep trying. Know that it exists and you will find it. Okay. And so just, it will work out. So a categorical variable can either be classified as ordinal or nominal. And of course, there are further classifications. But in general, an ordinal variable has natural ordering, right? What year of school are you in? First year, second year, third year, fourth year, right? That's the only way I would list those things, right? I wouldn't say third year, I can't even do it. Third year, first year, second year, fourth year. No, that doesn't make sense, right? There's natural ordering there, okay? And so here, right, ordinal has natural ordering. Could even talk about letter grades is the example I steal from my notes here, right? What grade did you get? A plus, A minus, B plus, B, right? You wouldn't go in any other order, right? Whereas nominal has no natural ordering, right? It all hinges on the natural ordering, right? And so a nominal category is the color of the car, right? Red, silver, blah, blah, blah. I'm just looking, yeah, all I see is red, silver, black, white. Okay, I see a lot of colors, but anyways, right, there's no natural ordering here. Sure, you could alphabetize them, but you don't have to, right? There's nothing that says, oh, that's weird if you didn't, right? But here's so no natural ordering. And my example was car color. Any color, really. Numerical variables, same idea, can be split into, well, I guess not really same idea, but similar idea. Numerical variables, oh, I'm doing blue here, can be continuous or discrete? Here's where it gets a little bit confusing, and kind of the reason I don't talk about it too much is because, well, one, the analyses for continuous and discrete data is the same, right? It's very rare that we need to kind of think about which one it is, okay? But it can also be really confusing. So if I tell you how old I am some measurement, right? But I would just tell you, now I can never remember how old I am. I'm born in 86. You guys do the math. Right? Surely you're not, it's not your birthday today at this very moment. No, of course not. Right. But I would just say that I'm 36 or 7. It's in April, so 36. Feels good. Right. I'm 36 and some number of days and some number of hours and some number of minutes. Right. It's continuous. Right. But the way we report it is discrete, right? So sometimes, right? And so these terms kind of come naturally as well, right? It's kind of, I consider it my job to just show you that you already know statistics. You already know all this stuff, right? It's in here. You just didn't put it like this, a mess, right? And so a continuous measurement is often a decimal, right? It's on a continuous scale, right? And if you had a better way of measuring something, right? Speed, for example, right? Your car tells you you're going 20. Of course, you're not going exactly 20 kilometers per hour, right? If you had a better measurement, you could get a more precise measurement, right? It's continuous. And so here, how I kind of classify them is continuous is often a decimal. And discrete are usually counts like age, for example, right? But it gets very difficult, especially when you're beginning to tease those two apart, right? So that's why I say, don't worry about that. Just know that it can be done. It does exist, but the analyses rarely change. So for us, we're going to focus on these classifications, right? And don't worry about the others. Okay. So let's bring it back to why do we have data to talk about these different variables, right? Why do we collect data in the first place? It's to answer some research question, right? So some question that we have about our population, right? And so there's another way that we can slice and dice these variables. Okay. And let's just start with, we collect data, to try to answer a research question. So we're trying to answer some research question, and it's the curse of the statistician, right? I'll never commit to anything, right? There's always a probability that I'm wrong, right? And that's what we're going to learn later on, right? There's always a chance that we don't answer the research question. So we try to answer the research question, right? And so, and that's something that I want you to pay attention to and hopefully adopt as well, is that there's always a chance that we're wrong, right? And so, so you don't want to go in guns blazing and say, this is correlated with this and this belongs here. And there's always a chance that the data that you used to learn that was collected incorrectly, right? There's always reasons why things can go wrong, okay? And so in terms of a research question, right, we usually have one main variable that we're interested in, probably, let's say, the loan amount, right? So we have some response variable. Okay. And so the main variable of interest is called the response, or of course, there's more terms that we could use, especially in data science, the list goes on, but in general, we can call it the dependent variable, right? And so the response or the dependent variable. Okay. In data science, they go on to classify things as the target or the outcome, right? But once you get there, you'll easily be able to link it to just the response. So I'm going to call it the response variable. I rarely call it the dependent variable, but some fields do. And so the response variable is the thing that I'm interested in, right? Looking at that data set that we had open or not open here, right? I don't know what the research question was, but looking at my options here, right, just kind of gut reaction, I'm interested in looking at the loan amount, right? How does the loan amount, right, depend, on these other variables? Or on the flip side, how do these other variables explain changes in the response variable, right? We get the term response variable, and then anything else, I'm going to call them explanatory variables, right? Because we use them to try to explain changes in the response. Okay. So let's see here. Maybe I'll do a little bullet like that. Any variables, usually more than one, that could help explain changes in the response variable are called explanatory or independent variables. Explanatory or independent variables. Man, it's hot in here. Weird. Thought for a second I was running out of time. Hey, these windows don't even open. I guess we're on the second floor, so it'd be kind of weird. Someone's like, this is too much. Okay, so the reason I like to use explanatory instead of independent is because to me, it triggers, okay, the explanatory variables are trying to explain the response. Okay. Another way that things could get confusing, right, is we could use the same data to answer multiple research questions, right? But for each question, right, there's only going to be one response, and then everything else is the explanatory variable, right? So our main one that we started with was, okay, the loan amount. How does it depend on all these other variables, right? How does it depend on the interest rate, the term, the grade, blah, 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 home ownership, right? What if I wanted to know, I could change the research question, right? Or I could answer a different research question. What if I wanted to know about how does home ownership depend on the rest of these variables, right? That's something we could be interested in as well, right? So then all of a sudden, home ownership becomes the response variable, changing all these other ones to explanatory variables. So it depends on what question we're trying to answer, right? And that can be really kind of tough in the beginning, right? But we need to be flexible, right? What if I wanted to know about the interest rate, right? How's the interest rate affected by all these other variables, right? Is it dependent on these other variables? Okay. So the response, okay, let's see here. Let me underline the response and explanatory because those are the key terms here. There's an internal method to my madness with the colors, but I'm pretty inconsistent, so I don't want to tell you. But pink is important and sometimes just for fun. So all right. Usually we want to look at a relationship between these response and explanatory variables, right? And so one of the ways that we can do that is we can visualize it with a scatter plot. Okay? And this is, we're going to touch on this and then we're going to parking lot it until, I don't know, later, right? But it's good to be aware of a scatter plot. I know you have all seen scatter plots, right? Got a variable here and a variable here. Here a variable, here a variable, everywhere a variable. Dots, right? We've all seen a scatter plot, but I want to introduce them here because the rest of the textbook assumes that you know what a scatter plot looks like. I should probably tell you. So we will want to examine the relationship between a response and an explanatory variable, and usually we only focus on one explanatory variable at a time, potentially two, right? But for simplicity, let's just talk about one. So we will want to examine, if I can spell, the relationship between a response and one explanatory variable. Oops. Response and one explanatory variable. I'll clarify at a time. And where the key is to visualize the relationship. We use to all right, you've got the y-axis. Our internet. But it's still recording. Okay. Okay. Hopefully that's okay. Like I said, we'll see. So this course, we kind of take people from all different kinds of backgrounds. I'm going to assume that it's been a while since you did some math. If you're up to snuff on your math, great, right? And just kind of take the easy way, right? But it's a while, but I'll do a little refresher, okay? So don't be offended if you're like, yeah, of course, that's the X and the Y axis. That's hard to remember if it's been a while, okay? So on the Y axis, we're gonna put our response variable or dependent variable. So it'll always put the D variable. And of course, kind of random dots, I'll make them a little bit bigger. These, of course, are XY combinations, right, of my response and my explanatory variable, right? If X is this, Y is this, if X is this, Y is this, right? And so here I like to, or we will, not just I like to, I will always put the explanatory variable. The explanatory or the independent variable, just to solidify that that those are the same, right? They mean the same thing. I like to use the term explanatory because it highlights to me that has to go on the x-axis, right? It's kind of a quick reminder, okay, if I know which one goes on the x-axis, then the other one goes on the y-axis, right? A lot of what we're doing, if you can just remember one part, you'll remember the other part by default, okay? And I'll bring it up again probably once in your, so linear regression is when we fit a line of best fit here. But I had a student, because sometimes even remembering which one is the X and which one is the Y is a little bit difficult, right? And so I remember I had a student a long time ago, and she goes, oh yeah, I can never remember. So she imagined like a little guy down here. I'll do him in light blue. Little guy down here. And he was like, no, because the y-axis was falling on him. Because it was all like timber. Anyways, I just think that's probably the cutest way to remember which one is the X and which one's the Y. No. Cute. So I always share that one because it's adorable. Now, for us in this course, our response variable will only be numerical, right? It's going to change a little bit, have a categorical variable here, right? Then we get into logistic regression, right? Which if we have time, we'll get into it, right? It's pretty fun, it's pretty cool. But usually we don't have time, but you'll see it in other courses, especially if you're in data science, okay? But that's when you have a categorical variable here. Okay, we're going to focus on a numerical response, okay? But we will be able to deal with numerical or categorical response, explanatory variables. So for us, in this course, we will only see numerical response variables in terms of regression, right? And so, and again, when I say regression, I mean fitting a line of best fit and you have a scatter plot, right? So as soon as you see a scatter plot, the analyses will be regression, okay? But for regression for us, we're just gonna have numerical response variables in regression analyses. Okay. We will be able to handle both numerical and categorical explanatory variables. to handle both numerical and categorical explanatory variables. What I want to say here is, okay, I look at the scatter plot, right? And I see that there seems to be some sort of relationship here, right? But one of the important things to remember is that unless these measurements are from a controlled experiment, I can only say that there's a relationship, right? There's something, there's an association between these two things, okay? I'm working very hard not to say that X causes a change in Y, right? The only way that we can talk about causation is through a controlled experiment, and that's very, very rare. Okay? And so that's just kind of a heads up, not necessarily for this course until much later, but just in your other courses, right? Just keep that in mind. And so a relationship between two variables. And I'm not going to specify numerical, categorical, but like I said, for us, we're only going to have numerical response variables. So that's implied now. So a relationship between two variables does not imply causation, or does not imply that the explanatory variable causes a change in the response variable. Oops. Causes a change in the response variable. So does not, right? And the kicker is the cause, right? Right. The only way that we can establish causation is through a controlled experiment. The only way to establish causation is through a controlled experiment. I think we know what an experiment is, right? You think back to maybe kind of grade school science, right? I'm thinking about grade 9 science for some reason, right? Where we had to, okay, I'm gonna run this experiment. I didn't control all my factors though. I did a very bad job, right? But we ran these experiments and we kind of understand, okay, you're working in a lab and you're controlling all the factors that would impact what? Your response, right? And so, and that's very, very hard to do, right? And so for that reason, we're gonna leave experiments behind, okay? It's again, its own field, right? It's experimental design, experimental studies, all that, ignore, right? And all our data will not be coming from experiments, which means that we can't say that X causes a change in Y, right? Which is what we want to do, but we cannot. Okay? We can say there's a relationship, but we can't say there's causation. So here, Maybe I'll add it. Do I add it here? Yeah. We will not consider experiments in this course. Okay. There might be some, right? And that's great. But if you just treat them as observational studies, then you're better off. So we will not consider experiments in this course. So if you're not considering experiments, then what are you doing? So think about, okay, in data science, what are we usually doing? Where does the data come from, right? It depends on what you're doing, but usually, right, we just observe information, right? Unless you're talking about clinical trials, and of course you're doing experiments, but the only change in your analyses stay the same. It's just your results are more precise. That's great, right? And so nothing really changes by not considering experiments, right? But it just changes the precision of your results, and that's a good thing. Okay. So for us, we're just observing information, right? We just go out and we look at how many people are clicking on our website, clicking on our ads, using, I don't know, some sort of platform, all that kind of fun stuff. And so for us, we're going to be talking about observational studies. Okay. So we will consider data from observational studies. Right. Which is basically exactly what it sounds like everything else in this course. You sit back and you observe information, right? You're not controlling anything, right? You might change. So in terms of, you guys talked about A/B testing, maybe? You have two different websites that you want to test, right? Which one is going to get you better traffic? Then you randomly tell people, send people to different versions of the website, and then you observe what they do on the website, right? Do they spend more time on website A versus website B, for example, right? Or whatever response you're interested in, right? Do they click on my ads more, right? It's all different things that we could consider. Yeah. Always. Okay. Yeah, there's always so what you're probably getting at is bias, right? Where we kind of say, oh, I'm going to send these people to this website and these people to this website. But the way to get around it, or at least the way to kind of curb it, is by randomly assigning people to different websites, for example, right? But there's always room for, okay, well, the people that I sent to that website were just more likely to buy stuff from my ads, right? Or something like that. But there's no way I can control that, right? And so it's something to be aware of, but usually we try our best to mitigate it. Usually we can't do anything about it. Observational studies, right? We basically just observe information is how I think about it. Now, observational studies can be either prospective, right? So looking into the future, right? And I collect data. I start today and then I collect data that's coming in, right? Or retrospective, where I look back and I say, okay, at the start of COVID, I know I'm going to try to not use it as my go-to example, but it's hard. It's hard not to. And who's in the health analytics program? Couple, yeah, like more than half. Ah, okay. Then maybe it is a good example. I don't know. It gets boring though. All right. COVID. Right. And so, right, if I want to do, okay, well, since the beginning of COVID, March 2020, I think we've all kind of decided it was the beginning, right, at least for us. I was desperately trying to get tests done before we had to move online. Nightmare. So observational studies can be broken up into two groups. And so we can have prospective studies where we collect future information. Or we can have retrospective studies where we consider past data. Of course, then there's really no controlling how it was collected, right? But that's just something to be aware of, not something that we can do anything about, right? And in terms of our analyses, it doesn't matter, right? Observational studies are observational studies. Yeah. Okay. Oh yeah, we've got a little bit more time. I'm going to use it. Okay. More terminology. The group that we're trying to learn about, of course, is our population, right? We take a sample, so a subset of the population, and that's where we actually get our information from, right? But the goal of statistics is to take this little bit of information and then infer information about the whole population, right? And so you'll see the term inference in future chapter, and that's what it's all about, is we take this sample information, right? I can calculate the average, I can calculate the standard deviation, I can calculate all these things on my sample because I have it, but then my goal is to use that to learn about what the population looks like. So, but that's way ahead, but it's good to know, good to know. So the subset, oh, sorry, I jumped ahead. The general group that we want to learn about is called the population. The general group we want to learn about is called the population. Highlight population. And the subset of the population that we collect information from is called the sample. The subset of the population or not want, that we collect information from is called the sample. There are some problems with having this kind of subset of the population. So when I took this course, which was a small while ago, I guess. A long time ago, I guess. The guy who taught it ended up being my supervisor for my master's later on. But anyways, most of the classes, I felt like all he was doing was drawing this. And he was one of those guys who like swore and spat in class a lot, right? He's like, and he's so loud. And I've got more stories about him that I bring up, and I don't know, not really my style, but it stuck, I guess. So maybe that's what I should be doing. Swear more in class. No, I won't. I'll try not to. I say that as if I swear normally. I don't. This is what he would draw almost every class, or at least that's what it felt like, right? You've got your population, you got your sample. Yes, obviously. And I just remember thinking, why does he keep drawing that thing? This is so basic. Of course, I understand. I get it. The sample is a subset of the population. Until now I'm teaching and I'm like, it's very important that you remember that the sample is a subset of the population. We're trying to use this information to learn about this whole group. Another problem that we face, and one of the major issues, especially in the beginning, is we're going to have a sample average, right? So an average that we can calculate from the sample, but what am I actually interested in? I'm actually interested in the population average of whatever it is we're measuring, right? That means we need notation to denote which group it came from, right? So we'll do that tomorrow because I need you fresh for that, okay? But it does introduce this kind of this problem of, okay, well, I'm gonna have sample information. How do I denote that? And I'm gonna have corresponding population information. How can I keep those apart, right? And that's one of the main reasons that people tend to get confused with statistics as we're studying it. Okay. I'll save this for tomorrow as well. I was going to talk about bias, but save something fun for tomorrow, right? If you have any questions, let me know. Otherwise, I'll see you tomorrow for a 50-minute blip. And I'll stop this